All right, welcome back to our unit on stoichiometry. Today's topic is limiting and excess reactants. Lesson 2 of 3, your objectives are as follows. To learn the difference between the limiting and excess reactants in a chemical reaction. To learn how to calculate the limiting reactant using moles and grams of reactants. Okay, and finally, to learn how to calculate the amount of product that can form from the limiting reactant. Okay, for your quick write. Recall our simple sandwich recipe below, where 2 slices of bread require 1 slice of meat to produce 1 complete sandwich. Okay, imagine you go to the kitchen to make a sandwich. As you take out the ingredients, you realize that you have 1 piece of bread, 1 slice of meat. Okay, what ingredient limited or affected your ability to make a complete sandwich? Now consider the reaction below. Imagine you're a chemist and you'd like to make 2 molecules of ammonia. When you get to the lab, you realize that you have only 2 molecules of N2 of nitrogen and only 2 molecules of H2. How many molecules of ammonia are you able to make? What limited your ability to make this many? Okay, go ahead and pause this while you do your quick write. I'm going to move on. All right, so limiting and excess reactants. Once again, consider the reaction below. Notice the balanced chemical reaction corresponds to 1, 3, and 2. Okay, in other words here, this means that for every 1 N2 molecule or mole reacted, okay, we require 3 moles or molecules of H2. Okay, and for every 1 N2 molecule or mole that reacts, okay, 2 molecules of NH3 or moles of NH3 will be produced. Okay, and for every 3 H2 molecules or moles that react, okay, 2 of these NH3 molecules or moles will be produced. So this can be illustrated by the animation below. Okay, so we have 3 H2 molecules and 1 nitrogen molecule will react, okay, to produce 2 ammonia molecules, okay, our products. But what if I carried out this reaction by adding 3 N2 molecules and 9 H2 molecules to our reaction flask here? Okay, so let's add 3 N2 molecules, 9 H2 molecules, okay, which should make 6 NH3 molecules, okay? Okay, so yeah, we made 6 NH3 molecules here. So notice that all of the N2 and all of the H2 is used up and converted to NH3 in this example. Well, both reactants being completely consumed or used up is extremely uncommon. So usually one runs out first, which causes the reaction to stop, and the other reactant is left over. So what if I carried out this reaction by adding 6 N2 molecules and 9 H2 molecules to our reaction flask here? Well, let's see what happens. All right, well, we made 6 molecules of ammonia, but something is used up and something is left over. So notice, after the reaction has run to completion, 3 N2 molecules remain and have not been used up. In chemistry, we say N2 is what we call the excess reactant. It's left over. Well, the reactant that is not consumed or used up in the reaction is the excess reactant. Okay? In this example, H2 is what we call the limiting reactant. The limiting reactant is the reactant that is completely consumed or used up in a reaction and determines how much product can form. Okay, in this case, ammonia. So it is important to realize that because the limiting reactant is consumed or used up first, it limits the amount of product produced. In this case, NH3 that can form. So for your notes, what is the difference between the excess and limiting reactant? Okay, go ahead and pause this while you write. I'm going to move on. All right, so calculating the limiting reactant. Once again, consider our previous balanced reaction below here. What is the limiting reactant if the above reaction begins with 6 moles of N2 and 9 moles of H2? So step 1, divide the moles of each reactant given in the problem by the moles or coefficients given in the balanced chemical reaction. So let's do that. We're starting off with 6 moles of N2 divided by 1 mole of N2, which gives us 6 moles of N2. Okay, now for H2. Okay, we have 9 moles of H2 divided by 3 moles of H2, which gives us 3 moles of H2. Okay, so step 2 here. Compare the two results. The lower number is the limiting reactant. So in this case, okay, what is the limiting reactant? The answer comes from the following comparison. Okay, where 3 here is less than 6. Okay, so our limiting reactant, okay, because 3 is less than 6, H2 is the limiting reactant. Okay? All right, now it's your turn. Go ahead and practice. Okay, what is the limiting reactant if the above reaction begins with 3 moles of N2 and 10 moles of H2? Okay, go ahead and practice this. Okay, pause this while you work on this. When you're ready to check your work, hit play. Okay, let's see how you did. So, divide the moles of each reactant given in the problem here, 3 and 10, okay, by the moles or coefficients given in the balanced chemical reaction, 1 and 3. Okay, so 3 moles of N2 divided by, okay, 1 mole of N2, okay, gives us 3 moles of N2. Now for H2, we're starting with 10 moles of H2 divided by 3 moles of H2, gives us 3.3 moles of H2. Okay, so step 2, compare the two results. The lower number is the limiting reactant. So in this case, okay, what is the limiting reactant? Well, because 3 here is less than 3.3, okay, N2 is our limiting reactant this time. Okay, hopefully you got that right. All right, so limiting reactant problem given moles of both reactants. Okay, so consider our previous balanced chemical reaction we've been working with here. Okay, how many grams of ammonia can form if the reaction begins with 2 moles of N2 and 3 moles of H2? This reaction is different because first it's asking you to determine the limiting reactant, then, okay, how many moles of ammonia can form based on our limiting reactant. Okay, so step 1, solve for grams of product using the moles of the first reactant. So we have 2 moles of N2 we got to start with here. Okay, we know that 1 mole of N2 will produce 2 moles of NH3, and we know that 1 mole of NH3 has a molar mass of 17.04 grams of NH3. Okay, our units cancel, and we can get 68.16 grams of NH3, starting with 2 moles of N2. Step 2, solve for grams of product using moles of the second reactant, 3 moles of H2. Okay, so 3 moles of H2, and we know that, okay, 3 moles of H2 will produce 2 moles of NH3, ammonia, and we know that 1 mole of NH3 has a molar mass of 17.04 grams. Our units cancel, giving us 34.08 grams of NH3. All right, so step 3, compare the two results and determine the amount of product that can form from the limiting reactant. Okay, so because 34.08, okay, is less than 68.16 and produces a smaller amount of product, NH3, H2 is the limiting reactant and will run out first, therefore only producing 34.08 grams of ammonia. Okay, so this is how much ammonia can form because our H2 runs out first. All right, so for your notes, what are the steps for solving limiting reactant problems when given moles of reactants? Okay, go ahead and write this. When you're ready to move on, hit play here. All right, so practice here. Consider our previous balanced chemical reaction here. How many grams of ammonia can form if the reaction begins with 1 mole of N2 and 3.9 moles of H2? Okay, go ahead and pause this while you work on this. When you're ready to check your work, hit play. All right, let's see how you did here. All right, so step 1, solve for grams of product using the moles of the first reactant. All right, so we have 1 mole of N2, okay, and we know 1 mole of N2 will produce 2 moles of NH3 according to our balanced chemical reaction, and we know 1 mole of NH3 has a molar mass of 17.04 grams. All of our units cancel, okay, and we're left with 34.08 grams of NH3 can form from 1 mole of N2. All right, step 2, solve for grams of product using the moles of the second reactant, H2 here. So 3.9 moles of H2, we know 3 moles of H2 will produce 2 moles of NH3, and we know 1 mole of NH3 has a molar mass of 17.04 grams. Our units cancel, okay, and we can get 44.3 grams of NH3 from 3.9 moles of H2, okay? So step 3 here, compare the two results and determine the amount of product that can form from the limiting reactant. All right, so because 34.08 is less than 44.3 and produces a smaller amount of product, okay, NH3, N2 is therefore the limiting reactant and will run out first, producing 34.08 grams of ammonia, okay? So only 34.08 grams of ammonia can form from our 1 mole of N2, our limiting reactant, okay? All right, so the last example problem we're going to learn about here are limiting reactant problems, okay, given grams of both reactants. So once again, consider our previous balanced chemical reaction here. How many grams of ammonia can form if the reaction begins with 14 grams of N2 and 7 grams of H2? Okay, well, solve for grams of product, step 1 here. Solve for grams of product using the grams of the first reactant. So we have 14 grams of N2. Okay, and we know 1 mole of N2 has a molar mass of 28.02 grams of N2. Now our mole ratio here, we know that 1 mole of N2 will produce 2 moles of NH3, and 1 mole of NH3 has a molar mass of 17.04 grams of NH3, giving us, okay, 17 grams of NH3 can be produced. Okay, step 2, solve for grams of product using the grams of the second reactant. So we have 7 grams of H2. Okay, well, we know 1 mole of H2 has a molar mass of 2.02 grams of H2. Okay, and we know 3 moles of H2 will produce 2 moles of NH3, and we know 1 mole of NH3 has a molar mass of 17.04 grams of NH3. Okay, our units cancel, giving us 39.4 grams of NH3. Okay, so step 3, compare the two results and determine the amount of product that can form from the limiting reactant here. Okay, well, because 17 is less than 39.4 and produces a smaller amount of product, N2 is the limiting reactant and will run out first, therefore only producing 17 grams of NH3 of ammonia, okay, or product, all right? Okay, so for your notes, what are the steps for solving limiting reactant problems when given grams of reactants? Go ahead and pause this while you write, okay? I'm going to move on. All right, so now it's your turn. Go ahead and practice here, okay? How many grams of NH3 can form if the reaction begins with 35 grams of N2 and 9.5 grams of H2? Okay, so go ahead and pause this while you try this problem. When you're ready to check your work, hit play. All right, let's see how you did here. Okay, so step 1. Using those steps you just wrote down, solve for grams of product using the grams of the first reactant. Okay, so we're starting off with 35 grams of N2. 1 mole of N2 has a molar mass of 28.02 grams, and we know 1 mole of N2 will produce 2 moles of NH3, okay, and 1 mole of NH3 has a molar mass of 17.04 grams, okay, the units cancel, giving us 42.6 grams of NH3 can form from 35 grams of N2, okay, moving on to step 2 now. Solve for grams of product using the grams of the second reactant. We have 9.5 grams of H2. Okay, so we know 1 mole of H2 has a molar mass of 2.02 grams of H2, and we know 3 moles of H2 will produce 2 moles of NH3, okay, and 1 mole of NH3 has a molar mass of 17.04 grams of NH3. Our units cancel, giving us 53.4 grams of NH3. Okay, our last step here, compare the two results and determine the amount of product that can form from the limiting reactant. Well, because 42.6 is less than 53.4, it will produce a smaller amount of product. So therefore, N2 is our limiting reactant and will run out first, therefore only producing 42.6 grams of ammonia can form from our limiting reactant N2. Okay, hopefully you got that right. Okay, these are challenging problems, but go back and watch it again if you still need help. Okay. All right, so summarize. Reminder, you can always write your own. Okay, so go ahead and pause this while you work on your summary, and we'll see you next time.